This is the video on radiation and X-rays. An X-ray is a type of medical imaging that can help diagnose a myriad of things. They are used to make images of solid objects, where different opacities represent the object's susceptibility to be penetrated by the rays. In the X-rays you're probably most familiar with, skin and soft tissues appear darker and more translucent, denser materials like bones appear lighter and more defined, and solid objects like metal appear bright white. This type of neuroimaging utilizes X-rays, or waves 1/100th to 10 nanometers long. These occur when an inner electron is removed and the other electrons have to rearrange in the orbitals. The photon released from this process is an X-ray. Both X-rays and gamma rays have some kind of radiation, making them dangerous to the body when exposure is prolonged. So, are X-rays dangerous? What is radiation, and how does it impact us? Radiation is all around us. Cosmic rays from the sun, radon, the Earth, and even our own bodies emit some forms of radiation. The man-made computer you're watching this video on emits some radiation, and so do certain things in the medical field. Low-frequency waves on the other end of the spectrum, like microwaves and radio waves, give off radiation, but since it's non-ionizing, it results in top-layer damage, like burns. Radiation was first discovered shortly after the development of the X-ray in 1895 and 96. Wilhelm Röntgen used currents in different vacuum tubes to create waves that penetrated his light-blocking screens and would eventually penetrate the skin and other tissues of his wife's hand when he took the first X-ray. Henry Becquerel found that uranium salts naturally emitted the same types of rays, and his student, Marie Curie, coined it as radioactivity. Becquerel, Curie, and her husband Pierre would all go on to win a Nobel Prize for their work. X-rays and gamma rays give off ionizing radiation, which causes damage at the DNA level. One or both of the strands can break, causing rearrangements and free radical formation. These alterations at the molecular level can result in irreversible damage to the body if certain precautions are not taken. Radioactive exposure is measured in Röntgen-absorbed doses, or RADs. 1 rad is the absorption of 100 ERGs of energy from all the radiation in 1 gram of material. The biological equivalent is a Röntgen equivalent man, or REM, which is the dose in rads times a set quality factor. Radioactive materials follow half-life decay, or N sub T equals N naught times 1/2 to the T over T half. For example, uranium-235 has a half-life of approximately 700 million years. This means for a dose of uranium to contain half of its radiation, we would need to wait 700 million years. Exposure limits for radiation are around 5,000 millirem per year in adults and 500 millirem per year in minors. A fatal dose is 600 Röntgen, which is the ionization that gives 1 coulomb of charge in 1 cubic centimeter of dry air. Radiation can cause cells to stop dividing, or hyperdivision of mutated cells can result in cancer. Radiation can even propagate to future generations via mutations in genetic material in oocytes and spermatocytes. Because of this, we wear protective gear when being X-rayed. Think of the big gown they put on you at the dentist's office, or how doctors stand outside the room when an X-ray is being performed. And for those who work in radioactive fields, there are strict exposure limits, even for specific body parts. So, overall, X-rays are safe. Otherwise, we wouldn't use them. And radiation is all around us. But when regarding high-frequency waves that cause ionizing radiation, it's important to always wear protective gear and limit exposure as much as possible. This ends the video on radiation and X-rays.